So after we understand the mnemonic instruction and operand, let's really see the instruction statement. So when we say an instruction, that's a statement that becomes executable when the program is assembled into machine code by the assembler. Of course, they will be executed at runtime by the CPU. So CPU will read that machine code and do the corresponding action. So in this class, we use the IA32 instruction set. So instruction usually look like this. They always have the mnemonic instruction. Mnemonic instructions, sometimes they have operand, sometimes they don't have. So that's why you can see the operand is kind of depends on how many operand you associate with your mnemonic instruction. So only the instruction, you see, mnemonic instruction is required. So operand kind of is required, but they are according to the mnemonic instruction, because sometimes mnemonic instruction may associate with zero operand. Then you have two options, okay? So if you have the comma associate how this statement will do, so then in assembly language, all the comma in one line, they were using the semicolon. So you start with semicolon, then you have some comma you will write. But if you use a comma, they only associate after the comma. So after the semicolon, what's your comments afterward in one line? If two lines, you need to have two semicolon. So that's the instruction. But sometimes instruction maybe have a code label associated with that. So that's why you see here the label is option. And also this label is the code label because that's the instruction. And remember, code label always associated with a colon. So that's why we can see that's a code label. The code label, the label name can be anything. It's not using the reserve word. So that's instruction look like. So then continue, we will see the instruction statement, for example. So instruction format example. Assembly language instruction can have between 0 to 3 operand. So that's why we say every time we say the instruction, the mnemonic instruction is required. But operand, because how they associate, they may have 0, they may have 1, they have 2, or they have 3. So those operand can be regist, can be a memory operand, can be an integer expression. So that's earlier we told you all the different operand. They can be integer value or integer expression, or in sometimes they can have the input and output port. Just in this class, we didn't talk about that. So there is a nature ordering of operand. So you need to follow what your instruction do. If you have two operand, the first operand we call destination operand. The second operand usually we call the source operand. So that's for the two operand instruction. So now let's give you all the example. So the first thing, some instruction, they don't have operand associated with that. Like STC, set carry flag. Or the opposite is CLC, clear carry flag. So they don't have any operand associated with that. They just set or clear carry flag. But some operands, they may have, so let me using other color, so you know that's operand. So some operand, they may have some instruction, they have only one operand. The typical one is we call the INC increment. So INC, we only increment by 1. So you only increment the next operand by 1. So you can increment and regist. You can increment a memory variable. So that's one operand. So then you have most instruction, they are associated with two operand. For example, add. So you see, since they have two operand, right? Usually two operand, we say the first one is the destination operand. The second one is source operand. So when you add ECX to EBX. Then you update EBX value. Or the sub, the same thing. Sub, you have destination operand and source operand. So you subtract 25 from the my byte. Then you update my byte with the result. So then add the same thing. Yeah, so you have source operand EAX. But you see here, you also can be the integer expression. So that's two operand. So then the same thing, let's make the color to show you that's the instruction. We have instruction, no operand, one operand, or most, they do the two operand. And also we have the three operand. So the three operand is I mode instruction. They have three operand. The first operand is the destination, and the two other operands are source operand. So they will multiply together, then update the data into the destination operand. For example, I mode. Okay, so EAX is the result. So we multiply EBX with 5, then we update the EAX value. So that's why here we say in this case, EBX is multiplied by 5. Then the product is stored in the EAX. So then the same thing, we're using the purple color to show the instruction. So all the instruction format, we just show you the mnemonic instruction with the operand. Of course, before that, they can have code label. Or you can see here, afterward, we have the comments using the semicolon. So that's instruction format example. So earlier we talked about you have the label, right? You have the memory address, or you have the memory variable. So actually the label or the memory operand we call identifier. So the identifier is a program chooser name. It might identify a variable, memory location, a constant number, or a procedure, or a code label. Okay, so that's what we call the identifier. So there are a few rules you need to be careful in assembly language. Okay, so in any identifier, they may contain between 1 to 247 characters. Also, that's really a lot. We definitely have enough. So one thing is remember, all the assembly language are not case sensitive. So if you have one code label, you call a code label you call target. So this target already being defined using the code label. So you cannot reuse that, no matter you change the uppercase, lowercase, because all the identifier or instruction in assembly language, we don't care the case sensitive. So then about the identifier, the first character has to be a letter. So this letter can be uppercase or lowercase. They also can be underscore or @ question or $sign. After the first letter, then you can have subsequent character. Afterward can be digit. So on the other thing is your first character cannot be digit. Or they can be letter but not digit. So most important thing, identifier cannot be the same as the assembler reserved word. So what is the reserved word? So here is we show you some reserved word. Reserved word cannot be used as identifier. If we want to see that, we are in the appendix A in textbook. So reserved words are not case sensitive. So the same thing, you see, just like reserved word, your instruction is reserved word. You cannot use that. instruction mnemonic cannot be used because they are reserved word. They have registered name. See, not case sensitive, cannot be used that. All the directive, you see we have .386, we have the .stack. They are all reserved word, which tell the assembler how to assemble program. Directive .data.code, they are reserved word. And remember, we have the size of our memory, the attributes, like the byte, like words, like D word, like Q word. They are all the reserved words in assembly language. So some operator used in the constant expression, you cannot do that. So later we will show you maybe some other operator like DUP. So then some predefined symbol, you cannot use that. So to make sure what is reserved word, you can go to Appendix A to check with that. Okay, so here actually we just go over some basic concepts. So that's pretty lecturing. So I hope you guys still awake. Anytime you can just pause the video. So the next one will be very simple. Is we call the integer constant. So integer constant, of course, you can just give them the number. They can be positive, negative for the sign. But one thing is I want to show you, because we have the decimal number, we have the hex number. So that's why after your digit, if you put the D is a decimal, H is hex. If nothing, we just represent as we just read as decimal. Or you see here you have a binary, that's a B. So because we have so many different number systems, that's very important in your integer constant. It's better you give them the radius to let us know which number system you use. And one thing about the hex lateral, begin with a letter. You must have a leading zero associated with that. Because sometimes if you only do the A5, right, they may treat that as a string. So the best way is before that, you just add 10 before your hex. So that we would interpret that as an identifier. So after you have integer constant, of course, you have the integer expression. So those integer expression will only work on the parentheses, plus, minus, multiplication, division, mode, or the sign. So those integer expression, you're only using the constant number to associate with that. So that's what we call the integer expression. You have 16 divided by 5. You maybe can be more complicated integer expression. But no matter which one, they're only using the integer constant number to do the operation. If we want to multiply or add any memory address or register, you need to write instruction for that. Otherwise, the simple calculation you can use in the integer expression. So sometimes we have the integer expression, and also one thing is we may define a string. So that we call the character and the string character. So when you have the character and the string constant, in assembly language, you can either using the single quote or double quote. They are all the same. It's different from C++. C++, we only using the single quote for the character, double quote for string. But in assembly language, when you enclose character or string in single quote or double quote, they all understand. So each ASCII character is 1 byte. So the same thing, if you want to enclose string, right, so they can be single quote or double quote. So here I'm using the purple color, just want to show you. Okay, so either single quote or double quote, they understand that's a string. So each character, of course, they occupy in 1 byte. They even can embed it with a quote. So that's why this one is your string. But the single quote, so that's why let me put it purple. So just tells you inside the single quote, they are all the string included with that. So the last one is comments. Comments is very important. Like we told you, they have many purposes you can read here. But one thing is, in assembly language, you're only using one semicolon, that's only single line comment.